one of the important theorem in triangles. Yesterday we discussed basic proportionality theorem. Next theorem is Pythagoras theorem. We are already familiar with this Pythagoras theorem from the grade 6, 7, 8 classes. Now, what is theorem and how we are going to prove this Pythagoras theorem now? Proof of Pythagoras theorem. First, the theorem in a right angle triangle. See, if you take one right angle triangle or a right triangle, here it is a ABC right triangle at B, right angle at B. The side which is opposite to right angle, that side name is hypotenuse. Side name is hypotenuse. Now already we know that this is a base and height, simply height of the triangle, base of the triangle, hypotenuse of the right angle triangle. So in the right angle triangle, always the square of hypotenuse value is equals to square of this longest side, hypotenuse AC. So according to the alphabets, here AC is the longest side, hypotenuse. That square value is equals to sum of squares of other two sides. What are those other two sides? AB and BC. So other two sides are squares. It means AC square plus BC square. So AB square plus BC square, or hypotenuse square value is equals to base square plus height square. In a right angle triangle, the longest side or side which is opposite to right angle, that is hypotenuse. So hypotenuse square value is equals to base square plus height square. This is the theorem. Now proof of this theorem. Proof of AC square is equals to AB square plus BC square. Hypotenuse square value is equals to base square plus height square plus base square, or base square plus height square, both of them same only. Now, so to prove this, before we need to discuss some more theorems regarding triangles, right angle triangles especially. We know the similar triangles and CPCT, congruence parts of corresponding triangles rules also we know that. Now ABC is a right angle triangle, right angle at B. If you draw the perpendicular to hypotenuse AC, now what I am doing, I am drawing one perpendicular to AC. From which one? From right angle of that particular triangle. Means from point B to side AC or hypotenuse, I am drawing one perpendicular at point D. So what I am doing, I am drawing a perpendicular line BD to AC side. So here this AC side is perpendicular to BD. Now what will happen in a right angle triangle? If you draw a perpendicular ADB and another one BDC, another one ADB and CDB, triangle CDB. So these two triangles are similar to each other and at the same time similar to whole triangle. This is the theorem which a triangle divided by a perpendicular from the right angle, then the two triangles are similar to each other and whole triangle also. Now here, to prove that Pythagoras theorem. What I am taking first? ADB triangle I am taking. Triangle ADB. Similar to old triangle. What is the old triangle? ABC. ABC. The smaller triangle ADB. See, if you take smaller triangle ADB, ADB, ADB. Here only right angle is there. So it means this is the height of the smaller triangle. This is the height of the smaller triangle, and this is the hypotenuse of the smaller triangle, and this is the base of the smaller triangle. Now, so both the triangles, the smaller triangle and old triangle, both of them similar triangle. When the two triangles are similar triangle, congruent parts of corresponding triangles are equal. It means are in equal ratio. So what I am taking both the heights. What is the height of the smaller triangle? What is the height of the bigger triangle? AB. What is the height of the smaller triangle? Height of the smaller triangle AD. Height of the bigger triangle AB. Height of the bigger triangle AB is equals to, what is the height of the hypotenuse of the smaller triangle? AB. What is the hypotenuse of the bigger triangle? AC. So first what we are taking? Heights of the smaller and bigger. Hypotenuse of the smaller and bigger. So if these two triangles are similar triangles, then sides, corresponding sides are in equal ratio. So the ratio of heights, here simple amma, ratio of heights is equals to ratio of hypotenuse. Ratio of heights is equals to ratio of hypotenuse. Now cross multiplication, AD into AC is equals to AB into AB, AB square, AB into AB, AB square. This is the first situation, and this one first equation. First equation. Now take the second situation and second problem. Triangle BDC, BDC congruent to triangle BDC congruent to ABC, old triangle, old triangle. Now here congruent spots. Here same BDC. What is BDC? BDC first base. Okay, draw the triangle like here. Right angle is there. It is BDC, and here opposite of right angle, then it is the hypotenuse. So it is base and it is height. Base and height. Now take base of smaller triangle and base of larger triangle. What is the base of smaller or height? This is the hypotenuse, height. So take both the heights of the smaller and larger triangle. Smaller triangle height. So CD is the height. CD is the smaller triangle height. What is the height of the larger triangle? AB is the okay. Take CD. CD is what? Okay, CD considered as base and this one height. So CD of the smaller triangle, CD is base of the smaller triangle. What is the base of larger triangle? BC. Next, hypotenuse of smaller triangle, BC. Hypotenuse of smaller triangle is BC. What is the hypotenuse of larger triangle? AC. Here in the previous problem what we took, height ratio is equals to hypotenuse ratio. Here base ratio is equals to hypotenuse ratio. Now cross multiplication, CD into AC is equals to BC into BC, BC square. This is the second equation. Second equation. Here, if you don't know the similarity rules, then it is difficult to find which two sides we are taking. First, we need to know the similarity rules. Now, first multiply first and second equations. What is the first equation? AD into AC plus add the first and second equation. AD into AC plus CD into AC is equals to AB square plus BC square. I am adding 1 and 2. 1 left hand side values, 1 and 2 right hand side values. So what is common in both of them? AC common. If you take AC common, AD plus CD. AD plus CD is equals to AB square plus BC square. AD plus CD. AD plus CD. What is the total value of AD plus CD? AC. So AC into AC is equals to AB square plus BC square. AC into AC, AC square. AC square value is equals to AB square plus BC square. AC square plus BC square. This is the proof. Finally, we got AC square value is equals to AB square plus BC square. Here, how we are taking the congruence, that is really important.